In this lesson, I'll show you how to find the eigenvectors of a matrix. In question 1, we're asked, find the eigenvectors of the matrix below. Take a close look at this matrix. We've actually already looked at this in one of our previous videos when I showed you how to find the eigenvalues. So I'll be borrowing some information that we found in that previous video for here, where the eigenvalues were equal to 1, 2, and 3. Now I'm referencing that video, so if you haven't watched it, make sure that you watch it before you do this one, because you can't find the eigenvectors without finding these 3 values that are specific for this matrix. Now in order to find these values, you actually had to subtract this matrix by lambda times its identity and find the determinant equal to 0. If you subtract lambda times its identity with this matrix, you should end up with the following matrix. And we'll need this for this example. You should end up with 4 minus lambda, 0, 1, minus 2, 1 minus lambda, 0, and negative 2, 0, and 1 minus lambda. So this is the resultant matrix after subtracting this from the original. And since we're making this matrix equal to 0, I'm going to add another column of zeros. Now for each of the eigenvalues that you find, you have to input them back into this matrix. So let's start with 1. You input 1 into here, and into here, and then after you input it, you'll have a 3x4 matrix which you have to put into row echelon form to solve. In case you're confused, here's what I mean. 4 minus 1 is equal to 3. The rest stay the same. Minus 2. 1 minus 1 is 0, 0, 0, negative 2, 0, 1 minus 1 again is 0, 0. You now put this in row echelon form, and if you do that correctly, I'm assuming you already know how to put matrices in row echelon form. In case you forgot, that's when the main diagonal has the 1s and everything below them is 0. So using a little bit of magic, this matrix in row echelon form should begin to look like this. There you have it. That matrix is not only in row echelon form, but it's also in reduced echelon form. That's when even these zeros, the ones above the leading ones, are zeros. That just makes things easier. So now that we have the following, notice that we have more columns than we have rows with leading ones. This means that we will end up with a few parameters. For example, if we set this column as x sub 1, this column as x sub 2, and this last column as x sub 3, x sub 2 will be a parameter because it doesn't have a leading 1. So we can set x sub 2 equal to any letter that we like. I'll use t. X sub 1, on the other hand, is equal to 0. Notice that this column represents our solutions. And x sub 3 is also equal to 0. As a result, our solution, which I'll represent as a column vector, is equal to x sub 1 being equal to 0, x sub 2 being equal to the coefficient of 1, and x sub 3 being equal to 0, multiplied to the parameter t. Now, you have to do this 2 more times for 2 and 3. In other words, you have to change these lambdas into 2 and then put that into row echelon form and solve, and the same thing with 3. So as you can tell, this is going to take a while to do. Because of that, I'm going to skip a few steps. Rather than showing all of the steps, I will show you what happens after you input the number 2 and then 3. So I'll show you this, and then I'll show you that, and I'll show you how to solve for the following. So let's go ahead and do that really quickly. So how do I put 2 into all of these? I should end up with a brand new matrix that looks like this. And if you put this now into row echelon form, you end up with another matrix that has the following elements. Now, once again, each column represents x sub 1 through sub 3 except for this one. We'll start over here. Notice that this time x sub 3 does not have a leading 1. So x sub 3 will serve as a parameter which I'll represent as t once again. On the contrary, row 2, we have x sub 2 minus x sub 3, which I can change with t, I'll do that now, is equal to 0. Solving for x sub 2, I have x sub 2 is equal to t, And for the first row, I have x sub 1 plus half t is equal to 0. I'll solve for x sub 1 very easily by bringing that over negative half t. Therefore, my answer can be summarized as this vector times t, where the first row is negative half, the second row is 1, and the third row is 1. We have to do this one more time, but instead of lambda being 2, it's now 3. So I'll replace this with 3, 3, and 3. You should end up with a matrix that looks like the following. And if you do the next part correct, where we put this in a row echelon form, the matrix in a row echelon form should look like this. Now, once again, each of these columns represent x sub 1 through sub 3. And once again, just like before, x sub 3 does not have a leading 1. So this will be our parameter, x sub 3 is equal to t. And starting over here, x sub 1 plus t, we're not going to write down x sub 3 for here because we've already set it as t, is equal to 0. Bring that over. We have x sub 1 is equal to negative 1 times t. For row 2, I have x sub 2 minus t is equal to 0. Bring that t over. We end up with simply that. And so our solution vector will be the following. Negative 1, 1. I'm taking those from here, here, and this one is 1. We have 3 vectors, 3 column vectors. Now I'll highlight them. This one, and that one. Those represent your eigenvectors. So let me write them down clearly for you. I'll rewrite this one, half, 1, and 1. Your other eigenvector, the one hidden up here, is 0, 1, and 0. And the last eigenvector is the one that I wrote here, negative 1, 1, and 1. And there you have it. That is how to find the eigenvectors for a matrix. If you want the answer to question number 2, make sure that you watch question 2 of this series, and we'll see you soon.